Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. It is our first lesson on a given mathematics form 3 topic, which is called further logarithm. So let me start by giving you the key information that you need to know as far as this particular topic is concerned. And the first thing you need to know is what we call the laws of logarithm. So let's start by highlighting the laws of logarithm. The first law of logarithm states that if you have logarithm to base c of a, then you add the logarithm to base c of b, then this one should always give you the logarithm to base c of a multiplied by b, that whenever you add, you have to multiply on the other side. The second law requires that if you have log to base c of a, then you subtract log to base c of b. This one is the same as saying log to base c of a, then divided by b, that when you subtract, you have to divide. The third law requires that if you have logarithm to base c of a to the power of n, then this one is the same as saying n log to base c of a, that this particular power can always be taken to pre-multiply the whole equation having the logarithm. Then the fourth law requires that if you have log to base c of c, this one will always be equal to 1. Then the other thing you need to know is that if you have the logarithm of 1, the answer will always be equal to 0. And the reason is because, for example, suppose you find the logarithm to base 10 of 1. Remember, 1 is the same as saying 1 to the power of 0, because a number to the power of 0 will always give you 1. So this is the same as saying 0 multiplied by, because I can take this one to pre-multiply this, 0 multiplied by logarithm to base 10 of 1, then 0 times a number, the answer will always be equal to 0. Then the other thing you need to know is conversion from logarithmic notation to index form and vice versa. So logarithmic notation, then we have the index form. You need to know how to interconvert. So for example, if you have a logarithm to base c of a being equal to b, this one in index form, this will be c to the power of b is equals to a. So this is what we call the logarithmic notation. Then this will be the index form. So you simply take c to the power of the number that is here, which is b, then it should be equal to a. A good example, for example, we can have a number like maybe logarithm to base 10 of 100. This one will always be equal to 2. So this is what we call the logarithmic notation. So that means the index form will actually be 10 to the power of 2 is equals to 100, which is actually true. Then we look at examples on how we can apply this particular laws. So, and our first example is a past cases equation done in the year 1992, paper 2, question number 10. So it reads, without using logarithmic tables, solve for x in the equation log into bracket 11 over 2 plus 2 log 11 over, that is 4 by 11, minus the logarithm into bracket of 5 over 22 is equals to 2 log 4 minus the logarithm of x. So we are simply going to apply the laws of logarithm, and the third law stated that we can always take this one to the power of that. Similarly, using the third law, this power can move to be to the power of 4. So this will be the logarithm of into bracket 11 over 2. Then we are adding the logarithm. I'm taking 2 to the power, so this will be 4 divided by 11. Then the whole thing will be to the power of 2. So this will be power 2 or squared. Then minus the logarithm into bracket of 5 over 22. Then the whole thing will be equal to the logarithm of 4 to the power of 2. I'm simply taking 2 on the power, then minus the logarithm of x. So this will be the logarithm into bracket of 11 over 2, then added 2, the logarithm into bracket 4 squared, you are going to get 16, 11 squared, you are going to get 121, then minus the logarithm into bracket of 5 over 22, then the whole thing will be equal to the logarithm of 4 squared will give you 16, then minus the logarithm of x. Now applying a combination of the first and the second law, which required that whenever you add you have to multiply, whenever you subtract you have to divide, it means that I'm going to factor out logarithm, then into bracket 11 over 2. Then of course, because we are adding, when you add you multiply, so this will be times 16 over 121. Then when you subtract you have to divide, so divided by 5 over 22. Then the whole of this will be equal to the logarithm into bracket 16. So when you subtract you have to divide, so 16 divided by x. So this is going to give us, if I simplify whatever is in the bracket, I'm going to remain with the logarithm. You can just feed this on your calculator. So 11 over 2, then multiplied by 16 over 121, then you divide with 5 over 22. So my calculator is giving me 3.2, or simply 16 over 5. So whatever is in the bracket is giving me 16 over 5, 16 over 5, which is equals to the logarithm. Of course, this other side I'll get 16 over x. So this will be the logarithm of 16 divided by x. Once you remain with one logarithm on the right hand side and the left hand side, you simply drop the log to base 10, so that you remain with 16 over 5 is equal to 16 over x. On cross multiplication, I'm going to have 16x is equals to 16 multiplied by 5. Then I divide through by 16, divide through by 16, so that the 16 will actually cancel out. So my value of x will actually be equal to positive 5. Then we look at our second example, which is also a past case equation done in 1993, paper 2, question number 4. So it reads, find or solve for x in the equation 2 to base 10 of x, then plus the logarithm to base 10 of 5 is equals to 1 plus 2, the logarithm to base 10 of 4. So it is a question worth 4 marks. So I'm simply going to apply the laws of logarithm. So the third law required that we can always take this one to the power. So I'm going to have the logarithm. So this will give me, I'm going to get the logarithm of, that is logarithm to base 10 of x squared. I've just taken these 2 to the power, then plus the logarithm to base 10 of 5. Then this is equals to, remember 1 is the same as saying log to base 10 of 10, because we said that whenever you have log to base c of c, this one will always be equal to 1, which means that I can rewrite as log to base 10 of 10, which will be equal to 1. Then I'm choosing base 10 because all the other logarithms are to base 10. If it were to base 2, for example, I'll choose logarithm to base 2 of 2. So this one will be logarithm to base 10 of 10, then plus, I'll take this 2 to the power. So this will be logarithm to base 10 of 4 to the power of 2. So this will be, if I apply the law which involved addition, whenever you add you have to multiply. So this will be log to base 10, then into, of course, x squared, then multiplied by 5. So this should be equal to log to base 10. Again, when you add you have to multiply. 4 squared is 16. So I'm going to get 10 multiplied by 4 squared, of course, which is 16. So if I drop log to base 10, I'm going to remain with 5x squared. That is x squared times 5, you'll get 5x squared, being equal to 4 squared is 16 times 10, I'm going to get 160. So this one is equivalent to 160. Therefore, x squared will be equal to 160, then divided by 5, which will give me 160 divided by 5. I'm going to get 32. So this one is equal to 32. Therefore, if x squared is equals to 32, it simply means that I'll take square roots on both sides. I also take square root here, so that x will be, the square root of a number is always plus or minus the root of 32. So 32 can be expressed as 16 by 2, so that means x will be plus or minus, so this will be 32 is the same as 16 multiplied by 2, which can be written as plus or minus the root of 16 multiplied by the root of 2. So this will be plus or minus root 16. You are going to get 4, because 4 squared will give you 16, then root 2. So therefore it means that either my x will be positive 4 root 2 or negative 4 root 2. But you realize that on the given question, if we pick the negative 4 root 2, on this equation, if you substitute here, you are going to end up with the logarithm of a negative number. And we know that the logarithm of a negative number does not exist. For example, if you press, for example, the logarithm into bracket of negative 10 on your calculator, the calculator will tell you math error because it does not exist. So the logarithm of a negative number does not exist. And that is why you are going to conclude and say that, therefore, our value of x will just be the positive value. Therefore, x will actually be equal to 4 root 2. So we are ignoring the negative one because the logarithm of a negative number does not exist. So if you substitute here, this part of the equation will be undefined if you substitute the negative. So x is 4 root 2, or you can also express it to 4 significant figures. So this is 4 times the square root of 2. You are going to get 5 point. So it is either this or 5.657. So I've expressed it to 4 significant figures. So the negative, you just show it on part of the working, but the answer will be the positive one because the logarithm of a negative number does not exist or is not defined. Then we look at our third example, which is also a past case equation done in 1994, paper 2, question number 14. It reads, find the value of x that satisfies the equation logarithm of 2x minus 11, then minus log 2 is equals to log 3 minus log x. So it's a question worth 4 marks. So we simply apply the laws of logarithm that whenever you subtract, you have to divide. So this will be the logarithm then into, so because we are subtracting here, we'll divide. So this will be 2x minus 11, then divided by 2. Whenever you subtract, you have to divide. Then this should be equal to the logarithm. Again, we are subtracting, so we divide. So this will be the logarithm of 3 over x. Once you remain with one logarithm on the right hand side and the left hand side, you simply drop the logarithm to base 10, so that you remain with 2x minus 11 over 2 being equal to 3 over x. On cross multiplying, we are going to have x into 2x minus 11 being equal to 2 multiplied by 3. So this will be 2x squared minus 11x is equals to positive 6, which can be written as 2x squared minus 11x minus 6 is equals to 0. So these are quadratic, so I can compare it with ax squared, then plus bx, then plus c is equals to 0. Therefore, my value of a will actually be 2. My value of b will be negative 11. Then my value of c will be negative 6. So I'm going to use the quadratic formula to solve it. So the quadratic formula requires that the value of x be equal to negative b plus or minus the root of b squared minus 4ac, then the whole thing divided by 2a. So this will be equivalent to negative b. So the b is negative 11. So this will be negative 11, then plus or minus the square root of b squared. So b is negative 11. So this is negative 11 squared, of course, which will give you a positive value. Then minus 4 times a is 2, then multiplied by c. My value of c is negative 6, then the whole thing divided by 2 multiplied by a. My a is 2. So this one means negative will give us plus 11, then plus or minus. This one you feed it on your calculator. So open bracket, negative 11 squared, then minus 4 multiplied by 2 multiplied by negative 6. I'm going to get 169. Then the square root of 169 will give me 13. So this part will give me 13, then the whole thing is divided by 4. So it means either x is equals to 11 plus 13 over 4, which is going to give me 11 plus 13, you'll get 24. So 24 divided by 4, you are going to get 6. So the value of x is actually 6. Or we can as well find the other possible. Or x can also be 11. Then we use this one as a negative. So 11 minus 13 over 4. So this will give me 11 minus 13, then the answer divided by 4. So this will give me negative a half, or negative 0.5. But again, we look at the question, what was x representing? So if I substitute my value of x, for example, in this particular case, if I substitute x as negative 0.5, I'll end up with logarithm of a negative number. And we know that logarithm of a negative number is not defined. Similarly, if you substitute negative a half here, the whole of this bracket will give you a negative answer. So logarithm of a negative answer does not exist. That is why we are rejecting x as negative 0.5 as the answer. Therefore, our value of x will actually be equal to positive 6, because the logarithm of a positive number is defined, but logarithm of a negative number from the given equation is not defined. That is why we'll consider x as being positive 6 as our final answer. Then we look at our fourth example, which is also a past cases question done in the year 1995, paper 2, question number 13. It reads, without using logarithmic tables, find the value of x in the equation log x cubed plus log 5x is equals to 5 log 2 minus the logarithm of 2 over 5. So it is a question worth 3 marks. So we simply apply the laws of logarithm. So the first law will help us take this 5 to the power of 2. Then of course when you add, you have to multiply. So this will be the logarithm of x cubed, then multiplied by 5x. When you add, you have to multiply, then is equal to logarithm of, I'll take 5 to the power, so this will be 2 to the power of 5, then minus the logarithm of 2 over 5. So this will be the logarithm of x cubed times 5x. I'm going to get 5x to the power of 4. Then this will be equal to 5x to the power of 4, which will be equivalent to, so power of 4. So this is equals to logarithm of, this will be 32. 2 power 5 is 32. Yeah, that is 32. Then minus the logarithm of 2 over 5. Then of course we know that when you subtract, you have to divide. So this will be the logarithm of 5x to the power of 4 is equals to the logarithm of 32. So this will be 32, then divided by 2 over 5 because of the subtraction. If I drop log to base 10, or simply the logarithm, I'm going to remain with 5 x to the power of 4 being equal to 32, then divided by 32 divided by 2 over 5. So this will be 5 x to the power of 4 is equals to, we know that when you divide, you have to multiply by the reciprocal. The reciprocal is 5 over 2. So of course 2 here, 1, 2 into 32, 16. So I'm going to remain with 5 x to the power of 4 being equal to 16 multiplied by 5. 16 by 5, I'm going to get 80. So this will be equal to 80. Therefore x to the power of 4 is 80 divided by 5. So x to the power of 4 is equivalent to, if you take 80 divided by 5, you're going to get 16. So 80 to the power of 5, you're going to get actually positive 16. Then we know that from this point you have to find the fourth root. So the fourth root of 16, I'll actually get 4. Remember, you can also use the factor method. So the fourth root will always give you a plus or minus as part of the answer, just like the square root, the sixth root, the eighth root, and so on. So this will give you x will be equal to, because the square root will go with the cube root, no, the cube will go with the cube root, which will be equal to the cube root of 16. If you press on your calculator, the answer will be 4. So this is how you press the cube root. You simply, on your calculator, you press digit 4, then, so you'll press 4, then shift, then we have this symbol here. So you press 4, then shift, press exactly that way, 4, shift, then we have this symbol here, then of course after that you press 16. So you press 16, then if you press equal sign, you will get the answer as 2. So the value of x will be 2, but because this was we are finding a fourth root, the answer should be plus or minus. So this is plus or minus 2, just like the square root and the sixth root. So it means either the value of x is positive 2, so either x is positive 2 or x will be negative 2. But if you look at the negative answer, if you substitute a negative 2 here, this will be 5 times negative 10, that is negative 2, which will give you negative 10. So logarithm of negative 10 is not defined, or it does not exist. So the logarithm of a negative number is not defined. That is why we reject negative 2 as the answer. Similarly, if you substitute negative 2 here, you will have negative 2 cubed, which will be negative 8. Logarithm of negative 8 is not defined. So it is only logarithm of positive numbers that is defined. Therefore, we'll conclude and say the value of x will actually be equal to positive 2 as our final answer. So we've come to the end of our class today. So in our next classes, we'll be looking at more examples involving further logarithm. Until next time, this is Kind Tuition Academy. Thank you very much.